scholars, welcome to another Smash Jam series, and today we'll be smashing the topic logarithm in JAMB Mathematics. Alright, now but before we solve questions on logarithm, before we smash logarithm, I want to take you on a journey of laws of logarithm. You need to understand the laws of logarithm because they are going to give you an edge in solving any question that comes your way. So let's look at the laws of logarithm. Laws of logarithm. Let's quickly look at the laws of logarithm. Right, so laws of logarithm. Now the first law of logarithm says that if you have log a base x plus log b base x, all right, now having it that these two logs have the same base and an addition sign is between them, you can bring them into one logarithm as log a multiplied by b all to base x, because they have the same base and addition sign is between them plus. All right, so a times b, that gives us log ab base x. All right, so this is one of the first laws of logarithm, or this is the first law of logarithm. Now let's look at another one. Now another one says if you have log a base x minus log b base x, now provided that they have the same base and subtraction sign is between them, all right, you can bring them into one logarithm and then it becomes log a over b base x. All right, log a over b base x. Now before I go further, these two laws, that's this first one and this second one that I have given to you, it can also be splitted. For instance, log ab base x can be splitted back into log a base x plus log b base x. I want you to note this. And also log a over b base x can be splitted back into log a base x minus log b base x. All right, this is very important. So this can be brought together into one log and they have this. This can be brought into a single log and you have this, and this also can be splitted into this. This also can be splitted into this. You need to know this. Let's look at more laws of logarithm. Now another one we'll be looking at is the law that says that log of the same base gives you 1. All right, so log x base x gives you 1. Log 10 base 10 is going to give you 1. Log 3 base 3 is going to give you 1. Log 1 base 1 is going to give you 1. All right, log of the same base gives you 1. Now another law we'll look at is the one that says if you have log a to the power of x base b, this power of a, which is x, can come behind this logarithm and then it becomes x log a base b. All right, x log a base b. Now another law that says that log 1 to any base gives you 0. Log 1 to any base gives you 0. Log 1 to base 100 is still going to give you 0. All right, you need to know that. Now we can prove this actually. Okay, this is log 1 base x is equal to 0, right? We can prove it and see if the log of 1 to any base gives us 0. Now 1 can be written as x to the power of 0 base x. All right, now according to this law, this first law, 0 can come behind and then it becomes 0 multiplied by log x base x. All right, that becomes x multiplied by log x base x. According to this law, gives us 1. Log of the same base gives us 1. So 0 times 1 gives us 0. So this proves, all right, this proves to you that log 1 to any base gives you 0. Let's go ahead and look at more laws of logarithm. We have a law that says that if you have log a base x is equal to b, right? If you have log a base x is equal to b, you can convert this to indices. All right, you can convert to indices. All right, this law helps you convert logarithm to indices. So how do we do that? To say what is here, a is going to be equal to this base to the power of what this logarithm is equal to, which is b. All right, so a is going to be equal to this base to the power of what this logarithm was equal to, which is b. Now another law we are going to look at is the law that says that if you have a to the power of log x base a, now as far as this and this are the same, all right, as far as this and this are the same, you are going to have your answer to be equal to x. All right, you're going to have your answer to be equal to x. The next law we're going to look at is the law that says that if you have log a multiplied log a base b multiplied by log b base a is going to be equal to 1. This is like the inverse of this. All right, so if you multiply this, you're going to have 1. If you have a logarithm in this form, log a base b multiplied by log b base a, you're going to have 1. All right, now let's look at the next law. All right, now the next law says if you have that log a base b is also the same as 1 over log b base a. All right, log a base b is also the same as 1 over log b base a. Now let's look at another law of logarithm. Now another law is called, this law is called the change of base law. All right, it's called the change of base law. It's called the change of base law. Now when you have a logarithm, let me say log a base c, and then a and c are not favoring each other, you can change the base. All right, you can change the base to a favorable base. Maybe let's say base b, so you can change it and it becomes log a base b over log c base b. All right, log a base b over log c base b. Like I said, this is called change of base. Change of base. Change of base. All right, this is a law that denotes change of base. All right, change of base. Now the last law we're going to look at is the law that says if I have log a base b to the power of x, all right, is okay, log a base b to the power of x, this power can come behind this log, but when it's coming behind this log, it comes as an inverse. All right, so this power of the base here, x, can come behind and it becomes 1 over x log a base b. All right, so these are the laws of logarithm. Having all these laws of logarithm, let's move to smashing JAMB questions on logarithm. Evaluate log 8 minus log 4 over log 6 minus log 3. Now let's do this. Now whenever you see a question on logarithm and there is no base given to you, know that that logarithm is in base 10 automatically. Just know that that logarithm is in base 10 automatically. All right, so this becomes log. I'm going to apply the law of logarithm because this is minus, all right, subtraction. So I'm going to bring them as division. So bring them into one log, it becomes 8 over 4. Now we are applying the laws of logarithm over log, the same here, 6 over 3. All right, so this becomes log. Now 8 divided by 4 is 2, that becomes log 2 over 6 divided by 3, that's 2, that becomes log 2. Now log 2 divided by log 2 gives you 1. Anything divided by the same thing gives you 1. So the answer is 1. Evaluate log 4 number 1 over 2 over log 20 or number 1 over 4. Now before we can solve this, we have to convert this mixed fraction to improper fraction. So we have 4 number 1 over 2 and we also have 20 or number 1 over 4. So let's convert this. 2 times 4, that gives us 8, plus 1, that gives us 9 over 2. All right, now 20 or number 1 over 4, 4 times 20 gives us 80. 80 plus 1, that gives us 81 over 4. So bringing this to here, we're going to have this to become log 9 over 2 over log 81 over 4. All right, log 9 over 2 over log 81 over 4. Now if you watch closely, 81, this is 81 over 4, this is already 9 over 2. Now 81 can be expressed as 9 to the power of 2. 4 can be expressed as the power of 2 to the power of 2. This is what I'm saying. 81 is equivalent to 9 to the power of 2. 4 is equivalent to 2 to the power of 2. So you are seeing your answer coming out from this, from here. All right, because this is log 9 over 2. All right, you have to be very, you have to foresee sometimes your answers before you even solve the question finish. All right, so now let's move on. So this is log 9 over 2 over, now this is log 9 to the power of 2 over 2 to the power of 2. So this is equal to log 9 over 2 over log, now 2 is come on here as a power, so you can bring it as 9 over 2 to the power of 2. All right, so you can do this. Now according to the law of logarithm, that says if you have log a to the power of x base b, that this can come behind and it becomes x log a base b. All right, so now when it comes behind, this becomes what? This becomes log 9 over 2 over 2 log 9 over 2. Alright, so now if you notice, log 9 over 2 takes away log 9 over 2. You're going to be left with what? You're going to be left with 1 here, alright? Because log 9 over 2 here remains 1, and then log 9 over 2 here is 1. So, but you're going to be left with 2. 2 times 1 is 2. So, you're going to be left with 1 over 2 as your final answer. So, your answer here is 1 over 2. If 3 log a base 2 plus 5 log a base 2 minus 6 log a base 2 is equal to log 64 base 2, find the value of a. Now, how do we do this? Now, there's a law that says that log a to the power of x base b, that this comes behind and it becomes x log a base b. Now, this time I am going to do a reverse. I can reverse this back as log a to the power of x base b. Now, this is what I'm going to use for this question. So I can reverse this. This is 3 behind this log. This is 5 behind this log. This is, I can reverse them. So if I reverse them, it becomes log a to the power of 3 base 2 plus log a to the power of 5 base 2 minus log a to the power of 6 base 2 is equal to log 64 base 2. Now, I can bring this together according to law in this law of logarithm, because this is, they have the same base, all right? They all have the same base. So I can bring them together. Plus, I know that plus tells me to multiply, and then subtraction minus tells me to divide. All right, so this becomes log all into a to the power of 3 multiplied by a to the power of 5 over a to the power of 6 all to base 2 is equal to log 64 base 2. All right, log 64 base 2. Now let's continue. Now, according to law of indices, this is a to the power of 3 multiplied by a to the power of 5. They are saying a, so add their powers. So this becomes what? Log a to the power of 8 over a to the power of 6 base 2 is equal to log 64 base 2. All right, log 64 base 2. Now let's continue. All right, let's continue. So continue from here. Now, according to law of indices, this is a to the power of 8, a to the power of 6. Now, this is a and this is a, so I'm going to subtract their powers. They're the same thing. I'll just subtract their power. So 8 minus 6, that gives me what? 2. So that's log a to the power of 2 base 2 is equal to log 64 base 2. Now, if you watch closely, this log has the same base as this log by the right hand side. The log by the left hand side has the same base as the log by the right hand side. So what is going to happen is that these are going to cancel each other. All right, so you're going to be left with a squared is equal to 64. Now this can only be done, this cancellation can only be done when they have the same base. All right, so now a squared is going to be equal to 64. Now you have to get a, the value of a, not the value of a squared. So you're going to take the square root of both sides. All right, take the square root of both sides. So square is going to cancel square root. So you have a is equal to square root of 64 is 8. Because if you multiply 8 in two places, you get 64. So the square root of 64 is 8. Log 4 minus log 2 over log root 8 simplifies to. Now, let's bring this together, and then it becomes log 4 over 2, right, over, now, this can be also written as log 8 to the power of 1 over 2. So this becomes log 4 divided by 2, that gives us 2. So this is log 2 over, now, this 8 has a relationship with 2. Looking at this log 2, it tells you how to express this. 8 can be expressed as 2 to the power of 3. So that becomes log 2 to the power of 3 multiplied by the 1 over 2 that was there before. Right? So this becomes what? This becomes log 2 over log 2 to the power of 3 times 1 over 2. That gives us 3 over 2. Right? Now this can come behind, and then it becomes log 2 over, this comes behind, and it becomes 3 over 2 log 2. Now if you notice, log 2 can take away log 2 from here. All right, so you're going to be left with what? You're going to be left with 1 over 3 over 2. And 1 over 3 over 2 means the inverse of 3 over 2. And what is the inverse of 3 over 2? The inverse of 3 over 2 is simply going to give us 2 over 3. So 2 over 3 is going to be our final answer. Simplify log 40.5 base 3 minus log 10.5 base 3. Now, we want to solve this question. Now, our advice, convert 40.5 to fraction before you start doing anything. So this is going to be 40.5, and also convert 10.5. Now this is 40.5, this is 10.5. Now move from the decimal point behind 1. So this is going to be 405 over, put your 1. How many times did you count? Once. So you put 1 0. Now convert this to, this is 1. This is going to be 105 over, put your 1. How many times did you count? Once. Alright. So this is 405 and 405 over 10 and 105 over 10. So you come back here. So this becomes log 405 over 10 base 3 minus log 105 over 3, sorry, 105 over 10 base 3, right? 105 over 3 base 10, base 3. Now, you're going to bring them together into one log, all right? You're going to bring them into one log as division. So it becomes what? Log 405 over 10 divided by 105 over 10, all right? All to base 3. Now, division must change to multiplication, all right? Division must change to multiplication. And for division to change to multiplication, the number by the right-hand side or the fraction by the right-hand side will be inversed, all right? It will be inversed. So this becomes log 405 over 10 multiplied by 10 over 105 base 3, all right? So now we notice that 10 takes away 10 here. Alright, we're going to be left with 405 over 105. So this is going to be equal to log 405 over 105 base 3. Now, we're going to reduce 405 over 105 to the lowest term because we can still divide 405 over 105. Because if you notice, 5 can go in 405 and 5 can also go in 105. Now, 5 goes in 5, you have 1. 5 goes in 40, you have 8, that's 81, right? Now 5 goes in 5, that's you have 1. 5 goes in 10, you have 2. So we're left with 81 over 21. Now if you notice very well, you notice that 3 can go in 81 and 3 can go in 21. 3 can go in both of them. So 3 in 81 gives you 27. 3 in 21 gives you 7. So you're left with 27 over 7. So this becomes log 27 over 7 base 3. You can split this into log 27 base 3 minus, following the law of logarithm, log 7 base 3. Alright, so now log 27 can also be expressed as log 3 to the power of 3 base 3. So it becomes log 3 to the power of 3 base 3 minus log 7 base 3. Now this comes behind, it becomes 3 log 3 base 3 minus log 7 base 3. Now log of the same base, of course, gives us what? 1. So 3 times 1 minus log 7 base 3. So 3 times 1, that gives us 3 minus log 7 base 3. So log 7 base 3, 3 minus log 7 base 3 gives us our final answer. Log 27 base 9 minus log 9 base 27 is equal to, this question is very, very trickish, but we are going to solve it. We're going to solve it. Now, this is log 27 base 9 minus log 9 base 27. We know that 27 and 9 have a connection, alright? 9 and 27, they have a connection. 9 is 3 to the power of 2. 27 is 3 to the power of 3. So what we're going to do now is that we're going to replace this, and then it becomes log 3 to the power of 3 base 3 to the power of 2 minus log 3 to the power of 2 base 3 to the power of 3. Now we're going to apply two laws of logarithm in this question. Now remember the law that says if you have log a to the power of x base b, that this comes behind and then it becomes x log a base b. Now there's also a law of logarithm that says that if you have log a base b to the power of x, the power of this base can come behind as an inverse, all right? So it becomes 1 over x log a base b. So we're going to apply these two laws here. So 3 can move back and then 2 can come here, but as an inverse. So if that happens, it becomes 3 over 2 log 3 base 3. Also here, 2 can move behind and then 3 moves under, all right, as an inverse. So that's going to become minus 2 over 3 log 3 base 3. And you know that log of the same base is 1. So this is going to become 3 over 2 multiplied by 1 minus 2 over 3 multiplied by 1. Alright, so this is going to be 3 over 2 minus 2 over 3. Now the LCM of 2 and 3 is what? The LCM of 2 and 3 is 6. So this is going to become 6. 6 divided by 2, that gives you 3. 3 times 3, that gives you 9, minus 6 divided by 3, that gives you 2. 2 multiplied by 2, that gives you 4. 9 minus 4, that gives you 5 over 6. So 5 over 6 is our final answer. Right? 5 over 6 is our final answer. Simplify log 256 base 4 minus log 4 base 4 plus 2. Actually, log 4 base 4 is going to be 1, right? But let's not do that. Let us use, because this and this are the same, let's bring them together. All right? We could have written this as 1, it's still the same thing, but let's bring this together. All right? Now, so this becomes log 256 over 4 base 4 plus 2. All right? Log 256 over 4 base 4 plus 2. Now, let's see 256 over 4. Can 4 go in 256? Now, let's divide. Now, 2 can go in 256 and it gives you 128 because this is 256. So you can split it like this, 256. 2 in 200 gives you 100. 2 in 56 gives you 28. So 100 plus 28, all right, that gives you 128. So this can also be easy for you to understand, right? Now 2 in 4, that gives you 2. So now 2 also in 128 gives you 64, all right, gives you 64. 2 in 8 gives you 4. 2 in 12 gives you 6, all right, then this is 2. So 2 here also 1. So you're going to be left with 64. That means 256 divided by 4 gives us 64. So this is going to be log 64 base 4. Right? Log 64 base 4 plus 2. Now, does 64 have a relationship with 4? Yes. 4 to the power of 3 is going to give us 64. You must know all this. You must learn this before your JAMB exams. Alright? You must learn this before your JAMB exams. So 4 to the power of 3 will give us 64. So this becomes log 4 to the power of 3 base 4 plus 2. Now this comes behind according to the law of logarithm, and it becomes 3 log 4 base 4 plus 2. This becomes 3 multiplied by log 4 base 4 gives you 1 plus 2. 3 times 1, that gives you 3 plus 2, which gives you 5. So 5 is the final answer to this question. If log 7.5 is equal to 0.8751, evaluate 2 log 775 plus log 750. Now, this question is very technical. Follow me closely. Now, this is log 7.5 given to you as this. Log 7.5 given to you as this. How can you manipulate 75 to be 7.5? And how can you manipulate this to be 7.5? Now, watch what I'm going to do. I can also write this as 2 log. Now, 75 can also be written as 7.5 multiplied by 10. Because 7.5 times 10 gives you 75. This 0 moves this, shifts this decimal backward, and then you still have 75. Alright, plus now this I can write this 750 as 7.5 times 100 this time. Alright, so this time this still gives you 750. Alright, so this is how you place this, because you are trying to shape this out, these two out into this. Right, so now I can split this into 2 into brackets log 7.5 plus log 10. Alright, and don't forget I told you that when a base is not given to you in log, just know that you are operating automatically in base 10. So this is actually base 10, this is actually base 10, right? So this is base 10, this is base 10, alright? Plus, now I can split this into log 7.5 base 10 plus log 100 base 10. Now, so I can now put it that I have this log 7.5 to be this, so it becomes 2 into bracket 0.8751 plus log 10 base 10 is 1, right, plus this is this, that's 0.8751 plus, now log 100 can be expressed as log 10 to the power of 2 base 100, sorry, base 10, right? Now this 2 moves behind, and then this becomes 2 into bracket 0 plus 0.8751 plus 1 gives us 1.8751, because this is like 1.00. So if you add it to this, it gives you 1.8751, right? Plus 0.8751 plus 2 comes behind, so you have 2 log 10 base 10, right? 2 log 10 base 10. And log 10 base 10 gives you 1. So let's continue from here. So we have this to be 2 times 1.8751. 1.8751 multiplied by 2. So this is 2. 2 times 5 gives us 10. So we write 0 and they take 1 out. So 2 multiplied by 7 gives us 14. 14 plus 1, that gives us 15. So we write 5, we carry 1 outside. Now 2 multiplied by 8 gives us 16. Plus 1, that gives us 17. So we write 7, we carry 1 outside. Now point 2 times 1 gives us 2, right? So 2 plus 1 gives us what? 3. So that's 3.7502. So this is going to be 3.7502 plus 0.8751 plus, now log 10 base 10 is 1. So that's going to be 2 times 1. Right? So this is going to be 3.7502 plus 0.8751 plus 2 times 1. That gives us 2. Alright? So now 2 plus 3.7502 is going to give us 5.7502 plus 0.8751. Right? So let's add this together. So we have 5.7502 plus 0.8751. So 2 plus 1, that gives us 3. 0 plus 5, that gives us 5. 5 plus 7, that gives us what? That gives us 12. So 2, we carry 1. 1 plus 7, 8. 8 plus 8, 16. So 6 carry 1. You put your decimal. 1 plus 5 plus 0, that gives us 6. So this is going to be 6.6253. So this is equal to 6.6253. This is going to be our answer for this question. So if given this, if we evaluate this, we're going to have 6.6253. If log 4 base 10 is equal to 0.6021, evaluate log 4 to the power of 1 over 3 base 10. Now, of course, we know according to the law of logarithm, we have to evaluate this and we are giving this. And according to the law of logarithm, 1 over 3 is going to come behind. So we are giving log 4 to the power of 1 over 3 base 10. Alright, so 1 over 3 comes behind and then it becomes 1 over 3 log 4 base 10. And you were giving log 4 base 10, so it becomes 1 over 3 multiplied by 0.6021. Alright, so it becomes 0.6021 divided by 3. Now, how do you divide this by 3? This is 21. This is 60. Or let me say this is 60 and this is 21. So 3 in 21 gives you 7. So you don't just put 7, you put 0 in front. Alright? This is the trick on how to divide this easily. Alright? Seeing that 3 can go in 21 and 60. Alright? So you put what? 0, 7. Alright? Now 3 in 60 now gives us 20. Alright? So you put your what? 20. Now then you put a point. Now of course 0 divided by 3 is 0, so this is going to be 0. So 0.6021 divided by 3 is going to give us this, and that will be the answer for this question. If log x squared base 3 is equal to minus 8, what is the value of x? Now to solve this question, we are going to use the law of logarithm that says that if you have log a base x is equal to b, and you can convert this logarithm to indices. Alright, and then it becomes that a is going to be equal to this base to the power of what this logarithm was equal to, which is b. We looked at this law at the beginning of this video, so let's apply this law here. That's the only way we'll be able to find the value of x here. So we'll say x squared is equal to the base to the power of what this logarithm was equal to, which is minus 8. Alright, now we can divide, this is x squared, this is 3 to the power of minus 8. We can multiply the power of both sides by 1 over 2. By the time you multiply the power of both sides by 1 over 2, it's going to eliminate 2 here. So you'll be able to find the value of x. So now multiply the power of both sides by 1 over 2. So it becomes x to the power of 2 multiplied by 1 over 2 is equal to 3 to the power of minus 8 multiplied by 1 over 2. Now it is very clear from here, now that you see that 2 now eliminates 2 here. That's why we multiply the power of both sides by 1 over 2. So now you are going to be left with x here is equal to, now also 2 goes here, 2 goes here, you're going to have 1, 2 goes here, you're going to have 4. So you're going to be left with minus 4, alright? So this becomes 3 to the power of minus 4. So x is going to be equal to 3 to the power of minus 4 can also be expressed as 1 over 3 to the power of 4. Alright, so this becomes, now 3 to the power of 4 is what? 81. Because it means 3 times 3 times 3 times 3 in 4 places, which gives us 81. Alright, 3 times 3 is 9. Another 3 times 3 is 9. 9 times 9 gives you 81. So that's the answer to this question. If log 18 base 3 plus log 3 base 3 minus log x base 3 is equal to 3, find x. Find x. Now, you have this. Now, if you notice, log 18 base 3, log 18 has the same base as all these. They all have the same base. But log 3 base 3 here gives us 1. So this becomes log 18 base 3 plus 1 minus log x is equal to 3. Alright, so I can take this here. 1 is a like term with 3. So take 1 here. This becomes log 18 base 3 minus log x base 3 is equal to 3 minus 1. Right, taking plus 1 here becomes minus. So now, according to law of logarithm, bringing this together, they have the same base and subtraction is between them, so it becomes division into one log. So it becomes 18 over x base 3 is equal to 3 minus 1. That gives us 2. Alright, now let's move further. Now we are going to apply a law of logarithm, the one we applied in the previous question that we solved. That what is here, 18 over x, will be equal to this base 3 to the power of what this logarithm is equal to 2. Right, so this is going to be 18 over x is equal to 3 to the power of 2. That gives us 9. Alright, so now we have to get our answer, of course. Yes, we have to get our answer. So we can cross multiply, right? So if you cross multiply, this becomes 9x is equal to 18 times 1 gives us 18. Alright, now 9 can go here 1, 9 can go here what, 2. So we are going to be left with x is equal to 2. So x is equal to 2 is going to be our answer. So x, the value of x here is 2. Given that log 2 is equal to 0.3010 and log 7 is equal to 0.8541, evaluate log 112. Right? When you see questions like this, your mind should work with numbers. Now, what numbers can I multiply that will give me 112 and will have factors of 2 and 7 inside, or that will have the number 2 and 7 inside of those numbers? Now, by the time you do a creative thinking, you should come out that 16 times 7 is going to give you 112. All right, 16 times 7 is going to give you 112. If you look at it very closely, 16 has 2 because 16 can be expressed as 2 to the power of 4. All right, 16 can be expressed as 2 to the power of 4, and then you have 7 here, which is this 7 here. So meaning that I can express log 112 as log 16 times 7. All right, then from here I can split it as log 16 plus log 7 according to law of indices and law of logarithm. Sorry, now you can express 16, like I said, as 2 to the power of 4. So it becomes log 2 to the power of 4 plus log 7. All right, now this goes behind. You're going to have 4 log 2 plus log 7. Alright, 4 log 2 plus log 7. So this is going to be, you are giving log 2 and log 7 already. So this is going to be 4 multiplied by log 2, which is 0.3010 plus log 7 which is 0.8451. Right, so now let's multiply this. So you have 0.3010 multiplied by 4. So this is 0, of course. 4 times 0 is 0, 4 times 1 4, 4 times 0 0, 4 times 3, that gives us 12 points. Carry 1 here, 1 plus 1. Now 4 times 0 gives us 4. Now 4 times 0 gives us 0 plus 1, that gives us 1. That gives us 1.2040. all right, so 1.2040 plus 0.8451. all right, so that is what we have there. So now let's go ahead and add this together. So we have 1.2040 plus 0.8451. That gives us 0 plus 1 gives us 1. 4 plus 5 gives us 9. Now 0 plus 4 gives us 4. 8 plus 2 gives us 10. we write 0, we carry 1. 1 plus 1 gives us 2 plus 0, that gives us 2. So this gives us 2.0491, right? 2.0491, and this is going to be our answer after we have this. So if we evaluate this, we are going to have this. Log 2 is equal to 0.3010 and log 7 is equal to 0.8451. Evaluate log 280. Now, like I said the other time, in the question we saw previously, you must be able to think of a number that gives you what you are given. You are seeing log 2 and you're seeing log 7. So you should be able to express 280 to have 2 and 7. Alright? That's how you solve questions like this. Now, let's analyze 280 because we have to evaluate 280. This is 280. First of all, we know that 28 multiplied by 10 gives us 280, right? Now, how will I multiply 28 to have 2 and 7 inside? Alright, how am I going to do that? What numbers can I multiply that will give me 28? Alright, that will give me 28. Now, and that has 2 and 7 inside. Now, if you watch very closely, 2 times 14 gives me 28. And I need 2. Also, 14 again, 2 times, now for 14 itself, 2 times 7 gives me 14. So I have everything I need, alright? So actually 2 times 2 times 7 times 10 gives me 280. So I already have everything that I need. So meaning that I can express log 280 base 10 as log 2 times 2 times 7 times 10 base 10 is equal to, now this is 2 times 2, so that's 2 to the power of 2, so that's log 2 to the power of 2 multiplied by 7 multiplied by 10. Now let's split them according to the law of logarithm. So it becomes log 2 to the power of 2 base 10 plus log 7 base 10 plus log 10 base 10. Alright, so splitting them according to the law of logarithm, that's what we are going to be having. So now let's continue. So 2 moves behind and then it becomes 2 log 2 base 10 plus, now this becomes log 7 base 10 plus log 10 base 10 of course gives us 1. Right, now this becomes 2 multiplied by, because we are giving log 2 base 10 already, 0.3010. Alright, plus log 7, which is 0.8451 plus 1. Alright, now of course 1 plus this gives us, this is still going to be 2 multiplied by 0.3010. So plus 1, this added with 1 is going to give us 1.8451. Just this one adds to this. Alright, now we're going to multiply 2 with this. Now if we multiply 2 times this, is going to give us what? This is 0.3010 multiplied by 2. So this is going to be 0, 2 times 0, 0, 2 times 1, 2, 2 times 0, 0, 2 times 3, 6, 2 times 0, 0. So that's going to be 0.6020. 0.6020 plus 1.8451. Alright, so let's add this. Let's add this now. Let's add this together. So we have 0.6, okay, let's put 1.8 up. 1.8451 plus 0.6020. So 1 plus 0, 1, 5 plus 2, 7, 4 plus 0, 4, 8 plus 6, that gives us what? 14. 4, carry 1, point, 1 plus 1 plus 0, that gives us 2. So our answer is going to be 2.4471, right? 2.4471. So 2.4471 is our answer. Evaluate log 8 base 2 plus log 16 base 2 minus log 4 base 2. Now, there are 2 ways to do this. If you notice, 8 has a relationship with 2, 16 has a relationship with 2, 4 has a relationship with 2. Or you can bring them, merge them together according to the law of logarithm. But to make things easier, let's use, since 8 has a relationship with 2, 16 has a relationship with 2, and 4 has a relationship with 2, let's express them as 2. So log 8 can be expressed as 2 to the power of 3 base 2, plus this can be expressed as 2 to the power of 4 base 2, minus this can be expressed as 2 to the power of 2 base 2. This comes behind, you have 3 log 2 base 2, plus this comes behind, you have 4 log 2 base 2, minus this comes behind, you have 2 log 2 base 2, right? So this is going to be 3 times log 2 base 2 1 plus 4 times log 2 base 2 1 minus 2 times log 2 base 2 1. This is 3 plus 4 minus 2. 3 plus 4 minus 2 gives us what? 3 plus 4, that gives us 7. 7 minus 2, that gives us 5. So 5 is our final answer to this question. Now let's take a second approach to this same question. Right, so this is log 8 base 2 plus log 16 base 2 minus log 4 base 2. They all have the same base, so I can bring them together into one log. Bringing them into one log, it becomes what? 8 times 16 divided by, because of minus, alright, so division comes here, over 4, alright, base 2. Now let's see how we can reduce this. Alright, so 4 goes here 1, 4 goes here 4, alright, 4 goes here 1, 4 goes here 4. So we are left with 8 times 4. Now 8 times 4 gives us what? 32. So you are going to be left with log 32 base 2. Now 32 can be expressed as 2 to the power of 5 base 2. So 5 comes behind. We're going to have 5 log 2 base 2. Alright, so log 2 base 2 gives us 1. So that's 5 times 1. So we have 5. Alright, so this is the answer to this question. If log 64 base x to the power of 1 over 2 is equal to 3, find the value of x. Because we are going to use the law of logarithm that says 64, we are going to convert this logarithm to indices. So it becomes 64 is going to be equal to this base, which is x to the power of 1 over 2, to the power of what this logarithm is equal to, which is 3. So I'll just simply be multiplying this by 3. Right? So I'm going to have what? I'm going to have 64 is equal to x to the power of 1 times 3. That gives me 3 over 2. Right, so it's still the same thing as saying x to the power of 3 over 2 equals 64. Now I'm going to multiply the power of both sides by 2 over 3. Why am I multiplying the power of both sides by 2 over 3? This is 3 over 2. It is only the inverse of 3 over 2 that can eliminate 3 over 2. Alright, so this is multiplied by 2 over 3. You see that 2 eliminates 2, 3 eliminates 3. Alright, so that's why I'll be multiplying the power of both sides by 2 over 3. So this becomes what? This becomes x to the power of what? 3 over 2 multiplied by 2 over 3. And then this also becomes 64 to the power of 2 over 3. That's multiplying both sides. So we know that this will be eliminated, and then we're going to be left with x is equal to, when we left with x is equal to 64 to the power of 2 over 3. Right? 64 to the power of 2 over 3. Now, we want to evaluate this now. 64 to the power of 2 over 3. What does it mean? Now you have x is equal to 64 to the power of 2 over 3. What does it mean? Now the number down, that's the denominator of the power, is 3. So that tells us that this will be cube root of 64 all to the power of, what's the numerator? 2. So x is going to be equal to, this cube root of 64 is what? 4. Because 4 times 4 times 4 gives us 64. So this is going to be 4. Now 4 to the power of 2. So that gives us 16. So x is equal to 16. Alright. So the final answer, the value of x here is 16. Calculate the logarithm of base 9 to 3 to the power of minus 4 multiplied by 9 to the power of 2 multiplied by 81 to the power of minus 1. How do we solve this? Now, this is 3, this is 9, this is 81. They all have a relationship with 3. Right? That should be at the back of your mind. So this is, and you are evaluating them, or you are calculating the logarithm of all these numbers to base 9. So we will have to evaluate this, then finally calculate it to base 9. Alright, to the logarithm of base 9. So now this is 3 to the power of minus 4 multiplied by 9 to the power of 2 multiplied by 81. So this is 3 to the power of minus 4 times, now 9 can be expressed as 3 to the power of 2 multiplied by the 2 that was there before. Alright, so this is going to be 2 times 2. Alright, the bracket means multiplication, multiplied by, now 81 can be expressed as 3 to the power of 4. Alright, then there was a minus 1 outside also. So now this is 3 to the power of minus 4 multiplied by 3 to the power of 4 multiplied by, now according to law of indices that says what, if you have x to the power of a all into b, these powers will multiply this one inside and outside, so it becomes x to the power of ab. All right, so we're going to apply that here, so it becomes 3 to the power of minus 4. All right, so now we're going to add their powers. Take one of them and add their powers. It becomes minus 4 plus 4 minus 4. All right, yeah, becomes minus 4 plus 4 minus 4. Now of course we know that minus 4 will take plus 4, so you're going to be left with 3 to the power of minus 4. You're going to be left with 3 to the power of minus 4. So you're left with 3 to the power of minus 4, and you were asked to calculate the logarithm of base 9 to this. So it becomes that you've calculated this, you've simplified this, and then you have this. So it becomes that you have log 3 to the power of minus 4 base 9. All right, because you're asked to calculate the logarithm of base 9 to this, to whatever you simplify. Now this is 3, this is 9. Can you express 3 or 9, sorry, in form of 3? Yes. So this becomes log 3 to the power of minus 4, and then this becomes 3 to the power of 2. All right, now according to this law of logarithm, all right, you have log a base x to the power of b. All right, this power of the base can come behind as an inverse. All right, and you also know that there's another law of logarithm that says the power of what is here can come behind. So when this comes behind and then this comes as an inverse, it becomes minus 4 over 2 log 3 base 3. That's, this comes as an inverse and then this comes behind here. All right, so now becomes minus 4 divided by 2, of course, gives us minus 2. Now log 3 base 3 gives us what? 1. So 2 times 1, that's going to give us 2. All right, so 2, no, not just 2, minus 2 is our answer to this question. All right, minus 2 is our answer to this question. Evaluate log 4 over 9 base 2 over 3 plus log 1 over e base e. Now this is 2 over 3 and this is 4 over 9. You can express 4 over 9 to something like this. That's 2 over 3. How? Because 4 is the same thing as 2 to the power of 2 and 9 is the same thing as 3 to the power of 2. So now what is going to happen now? This becomes what? This becomes 2 to the power of 2 over 3 to the power of 2. All right, and then you have it to base 2 over 3. Right, so now let's continue. So this becomes plus log, now 1 over e can also be written as e to the power of minus 1 base e. Now these have similar power, all right, so you can bring them out. This becomes log 2 over 3 to the power of 2 base 2 over 3 plus, now before we write plus, or before we do that, let's take minus 1 down here because the power of this can come behind. So it no longer becomes plus, it becomes minus log e base e. All right, now the power of these two can come behind. So when it comes behind, this becomes what? 2 log 2 over 3 base 2 over 3 minus log of the same base, log e base e gives us what? 1. Right, so now log 2 over 3 base 2 over 3 also gives us 1. So this is going to be 2 times 1 minus 1. Now 2 times 1 gives us 2 minus 1. That's going to give us 1. Right, so the answer to this question is 1. Given that m is equal to 2 log 2 base x and n is equal to log 5 base x, express log 0.4 base x in terms of m and n. Now this is a very tactical question. Now you are given m is equal to 2 log 2 base x, and you are also given n is equal to log 5 base x. So how do we work this out? Now let's focus on this for now. All right, so this is log 0.4x, sorry, 0.4 base x. Right, now let's convert 0.4 to fraction. So you have 0.4, convert it to fraction, move once. So that means it's going to be 4 over, put your 1. Then if you count once, it's just going to be 1 0. All right, just 1 0. Now reduce it to the lowest term. 2 goes here, you have 2. 2 goes here, you have 5. So you have 2 over 5. So this can also be expressed as log 2 over 5 base x. Log 2 over 5 base x. Now you can split this. You can split this into log 2 base x minus log 5 base x. Are you seeing it? Now, go back to what you were giving, because you have to express this logarithm in terms of m and n. In terms of m and n. Now, this is 2 log 2 base x, and this is n is equal to log 5 base x. I think this is already settled for this. This is n is equal to log 5. This is already settled. But how do we go about this? This is 2 log 2 base x. All right. Now, meaning that we have to find log 2 base x. So we are given m is equal to 2 log 2 base x. So what will be log 2 base x itself? Now, this is m is equal to 2 log 2 base x. Meaning we have to make log 2 base x subject of formula. We can divide both sides by 2, all right? So 2 takes away 2 here. So we are going to have it that log 2 base x is equal to m over 2. Are you seeing the beauty of that? So now, it means that log 2 base x is equal to m over 2. So from here, having known this, that from here, that log 2 base x is equal to m over 2. So this is going to be m over 2 minus, now log 5 base x is what? N. So this is going to be m over 2 minus n. And this is going to be our final answer. So the answer, this expressed in terms of m and n, is m over 2 minus n. If 6 log 2 base x minus 3 log 3 base x is equal to 3 log 0.2 base 5, find x. Now, this and this have the same base, all right? That's one thing to note. This and this have the same base, all right? Now, these two have the same base, but we are going to reverse their powers, all right? We're going to reverse them. So this becomes log 2 to the power of 6 base x minus log 3 to the power of 3 base x. All right, is equal to, now this is 3 log 0.2. Let's convert 0.2 to fraction. Now this is going to be 1, so this is going to be 2 over 10. All right, so 2 here goes 1, 2 here goes 5. All right, so this is going to be 3 log, this is also 3 log 1 over 5 base 5. Of course, you know that 1 over 5 can be expressed as 5 to the power of minus 1. So now this becomes log 2 to the power of 6, gives us what? 64. All right, gives us 64, because 2 times 2 times 2 times 2 times 2 in 6 places gives us what? 64. So this is going to be log 64 base x minus, this is going to be log 27 base x. All right, is equal to 3. Now 1 over 5 can be written as what? Can be expressed as 5 to the power of minus 1 base what? 5. Of course, you know that this comes behind, all right? So that you have log 5 base 5 and you have 1, and you're going to left to minus 3. So now let's continue from here. Bringing it into one log, it becomes log 64 over 27 base x is equal to, this comes behind, you have minus 3 log 5 base 5. All right, so let's continue. So what are we going to have left? We're going to have log 64 over 27 base x is equal to, now log 5 base 5 is 1, so that's going to be minus 3 times 1. Right, so this is going to be log 64 over 27 base x is equal to minus 3. All right, so now what's going to happen is that what is here is going to be equal to, we're going to apply the law of logarithm that says what is here, 64 over 27 is going to be equal to this base to the power of minus 3. All right, the base of minus 3. Now we're going to multiply both sides. We can also write this as x to the power of minus 3 is equal to 64 over 27. So we're going to multiply the power of both sides by 1 minus 1 over 3, because only the inverse of minus 3 is going to eliminate 3 from minus 3 from x, because we want to find the value of x, so we have to eliminate this from here so that we can find the value of x. So multiplying the power of both sides by minus 1 over 3, it becomes x to the power of minus 3 multiplied by minus 1 over 3 is equal to 64 over 27 to the power of minus 1 over 3. Now, so this becomes, of course, this eliminates this, all right? The minus also multiply themselves and then they are gone. So we're going to be left with x is equal to, now I told you, okay, from the law of indices, this is negative, all right, this is minus, all right? So in the power, so it tells you inverse, just do the inverse. So this becomes 27 over 64 to the same 1 over 3 to the power of 1 over 3, but the minus is gone, the negativity is gone, all right? So now this becomes, what does this mean? This means third root, all right? Third root of 27 and 64. So this becomes s is equal to third root of 27 over 64 all to the power of 1, all right? So x is going to be equal to, third root of 27 is what? 3, because 3 times 3 times 3 in 3 places gives you 27. Now what's the third root of 64? That's 4, all right? Because 4 times 4 times 4 in 3 places gives you 64. So the answer is going to be 3 over 4. If ln 10 is equal to 2.3, solve for x in the equation exponential 2x minus 1 is equal to 100. Now, they are giving you that ln 10 is this. When you see this kind of question, this is 100. So you know that you are taking the log of both sides. That's ln of both sides. All right. So take ln of both sides. Take ln of both sides, which is log of both sides. All right. So this becomes ln exponential 2x minus 1 is equal to ln 100. All right. Now, of course, according to the law of logarithm, this can go behind. So you're going to have 2x minus 1 ln e is equal to ln 100. Now, ln 100, because they gave you ln 10 is equal to this. Ln 100 can be expressed as 10 to the power of 2. All right? 10 to the power of 2. Now, so for this, I want you to know that ln e is equal to 1. Ln e is equal to 1. So this is going to be 2x minus 1 multiplied by 1, all right, is equal to, now 2 can come behind here, it becomes 2 ln 10, all right, 2 ln 10. So let's continue. So 2x minus 1 multiplied by 1 is still going to give us 2x minus 1 is equal to, now this is going to be 2 ln 10. 2 ln 10 is 2.3, so this is going to be 2 times 2.3, all right? So this is going to be 2x minus 1 is equal to, now 2 times 2.3, of course, is going to be 4.6. Take minus 1 to this side, becomes 2x is equal to 4.6 plus 1. 2x is going to be equal to 4.6 plus 1 gives us 5.6, all right? So now we have to get what? The value of x. So we divide both sides by 2. So x becomes 5.6 divided by 2. Right? 5.6 divided by 2. So 5.6 divided by 2. So of course, 2 goes in 5, that's 2.5. 2 goes in 0.6. That gives you what? 0.3. So 0.3 plus 2.5, that gives you 2.8. So the answer here is 2.8. Right? So the value of x here is 2.8. The value of x here is 2.8. Or you can do that 56 divided by 2, you get 28. Then just put a decimal in between 2 and 8. So the value of x here is 2.8. If log 2 base 10 is equal to 0.3010 and log 3 base 10 is equal to 0.4771, evaluate log 4.5. Now your main aim is to evaluate log 4.5, but you are giving log 2 base 10 and you're also giving log 3 base 10 as this and this. Now your goal is to find a way to express 4.5, log 4.5 in form of 2 and 3 so that you evaluate and get your answer. Now this is 4.5. Let's convert 4.5 to fraction first. So this is from here 1. So it's going to be 45 over, put your 1, then put 1 0. Alright. Now 5 in 45 gives us 9. 5 in 10 gives us 2. Alright. So this is 9 over 2. Now coming back here, meaning that you can express this as log 44.5 can become 9 over 2 base 10. Now you can split this into log 9 base 10 minus log 2 base 10. Alright, according to the law of logarithm. Now 9 can be represented as 3 to the power of 2. So it becomes log 3 to the power of 2 base 10 minus log 2 base 10. Of course, we know that this moves behind. And then this becomes 2 log 3 base 10 minus log 2 base 10. Alright, so now let's continue. Let's go further. Now we are given the value of log 2 and value of log 3 base 10. So it becomes 2 multiplied by log 3 is given to us as 0.4771 minus log 2 is given to us as 0.3010. Right? So let's use 2 to multiply this. So 0.4771 multiplied by 2 gives us what? Multiplied by 2 gives us what? So 2 times 1, 2. 2 times 7, 14, 4, carry 1. 2 times 7 again, 14 plus 1, 15, 5, carry 1, 1. Now 2 times 4, 8. 8 plus 1, 9. Alright, so this gives us 9 points. 2 times 0 gives us 0. So this is going to be 0.9452. 0.9452 minus 0.3010. Now let's subtract that. 0.9452 minus 0.3010. Alright, so 2 minus 0 gives us 2. 5 minus 1 gives us 4. 4 minus 0 gives us 4. 9 minus 3 gives us 6. 0 minus 0, of course, gives us 0. So our answer is going to be 0.6442. 0.6442 is our answer. Evaluate log 4 root 2 plus log 16 base 1 over 2 minus log 32 base 4. Alright, now this is 4, this is 16, this is 32. You should know that these numbers, they all have 2, a relationship of 2, and their root 2, although not properly expressed as 2, but you can express root 2 as 2 to the power of 1 over 2. You can express 1 over 2 as 2 to the power of minus 1, and you can express 4 as 2 to the power of 2. So you have to be very smart when it comes to solving questions like this. So it becomes log, this is 2 to the power of 2. This can be expressed as 2 to the power of 1 over 2. Alright? Plus, this is log 16 can be expressed as 2 to the power of 4. And then this base here, 1 over 2, can be expressed as 2 to the power of minus 1. Minus this can be expressed as log 2 to the power of 5. Now, this can be expressed as 2 to the power of 2. Alright? Now, don't forget the law of logarithm that says what? That if you have what? Log a base x to the power of b, that this b can come behind here. Alright, this b can come behind this log, and it becomes 1 over b log a base x. So that's what's going to happen. So but if this comes up, you know that this comes behind here, it becomes inverse. So if 1 over 2 is coming behind, the inverse of 1 over 2 now is going to be 2 over 1, which is still 2. Alright, so 1 over, when this comes here, it becomes 2 log 2 to the power of 2 base 2 plus, let's just settle this first. Now minus 1 comes here, it becomes 1 over minus 1, which still gives us minus 1. Alright, so minus 1 comes here, becomes what? Not plus again, change to minus log 2 to the power of 4 base 2. Alright, minus, now this comes behind here, but as an inverse, 1 over 2 log 2 to the power of 5 base 2. Alright, so now we are going to also apply the other law that says that this can come behind. Alright, so when 2 comes behind here, it multiplies this 2. So 2 times 2, alright, log 2 base 2 minus this comes behind 4 log 2 base 2. This comes behind minus 5 over 2 log 2 base 2. Now 2 times 2, 4. Log 2 base 2, of course, is 1. So 4 times 1 gives us 4 minus log 2 base 2 is 1. Of course, 4 times 1 gives us 4 minus log 2 base 2 is what? 1. Of course, 1 times minus 5 over 2 gives us minus 5 over 2. Now, 4 minus 4, of course, is 0. They eliminate each other. So we'll be left with minus 5 over 2. So minus 5 over 2 is our final answer. Minus 5 over 2 is our final answer. If log 2 base 10 is equal to x, express log 12.5 in terms of x base 10. Now, looking at this, we are given log 2 base 10 is equal to x, and we're asked to express log 12.5 base 10 in terms of x. Now this is 12.5. First thing I advise you to do is convert 12.5 to fraction first. So we have 12.5. So just take 1. So it becomes 125 over, put your 1. How many times did you count before you go to the last number? Once. Alright, so 5 goes in 125. It gives us what? 25. 5 goes in 10. It gives us what? 2. Alright, so this log 12.5 base 10 is equivalent to log 25 over 2 base 10. Now I can split this into log 25 base 10 minus log 2 base 10. Now, but there's a problem here. We are not giving anything that relates to 5 or 25. So how do we manipulate 25 to get 2 to become in form of log 2 base 10? How do we do that? Now, this is where critical thinking comes in. All right. Now, 100 divided by 4 gives me 25. 100 divided by 4 gives me 25. All right. 100 divided by 4 gives me 25. So what I'm going to do is that I can manipulate this into, why am I using 100 over divided by 4? Because I can evaluate log 100 is 10, and 4 can be expressed as 2 to the power of 2. All right. So this is what I am saying. So this becomes log 100 over 4 base 10 minus log 2 base 10. All right. Now, this, all right, can be split into log 100 base 10 minus log 4 base 10 minus log 2 base 10. What I'm trying to tell you is that 100 can be expressed as 10 to the power of 2, which can be easily evaluated because this is base 10. 4 can be expressed as 2 to the power of 2, which you are giving log 2. So we are going to get our answer from here. All right. So we can easily get our answer from here. So we move on. So this becomes log 10 to the power of 2 base 10 minus log 2 to the power of 2 base 10 minus log 2 base 10. All right. Take this behind, it becomes 2 log 10 base 10 minus, take this behind, it becomes 2 log 2 base 10 minus log 2 base 10. All right. So now log 10 base 10 of course is 1, so that's 2 times 1 minus 2. Now log 2 is given to you already as what? X. So that's 2 times x minus log 2 is still the same x. All right. So this is 2 times 1, 2 minus 2 times x gives us 2x minus x. All right. So minus 2x minus 2x, that's minus 3x. I borrowed 2 naira, I still borrow 1 naira. So that's minus 3x. So that's going to be 2 minus 3x, which is going to be our answer. So if you express this in terms of x, given this, you're going to have 2 minus 3x. So in this question, we are asked to solve the equations log x base 3 is equal to y is equal to log 2x minus 1 base 9. Now, of course, when they say solve the equation, we have to find the value of x and find the value of y. All right, so let's solve this. Now, they said log x base 3 is equal to y, meaning that log x base 3 is equal to y, and also y is equal to this. So y is also equal to log 2x minus 1 base 9. All right. So now we are going to apply for this, because this is a very technical question. It's going to lead us surely to a kind of equation, but let's go further. Probably quadratic equation. Yeah, it should. So now we're going to apply the law that says if you have log a base x is equal to b, you can convert this to indices. Then you're going to have a, what is here, is going to be equal to this power to the this base, sorry, to the power of what this logarithm is equal to, which is b. All right. So now we're going to convert this. So this now becomes what? Becomes that what is here, x, is going to be equal to this to the power of what this logarithm equals. So this is x is equal to 3 to the power of y. Let's just call this equation 1. All right. Now, also, we are going to apply it here. All right. So I can also express this as log 2x minus 1 base 9 is equal to y. All right. If y is equal to this is also equal to y. That's what I did. So let's apply this law here too. So it becomes that 2x minus 1 is going to be equal to this 9 to the power of what this logarithm is equal to, y. All right. All right. So now we are seeing 3 to the power of y here, and we are seeing 9 to the power of y here. Let's express 9 in terms of 3. So it becomes 2x minus 1 is equal to 3 to the power of 2 multiplied by the y that was there. So this will be 2x minus 1 is equal to 3 to the power of 2y. All right, 3 to the power of 2y. Okay, so now let's continue. So let's call this equation 2. All right, let's call that equation 2. Now, looking at this from here, you already have x is equal to 3 to the power of y. and you have 2x minus 1 is equal to 3 to the power of 2y here. Why not just substitute? Let's substitute equation 1 into equation 2. All right, so we are going to substitute equation 1 into equation 2. All right, so when we are substituting this, it becomes that anywhere we see x, we put 3 to the power of y. So it becomes 2 into bracket 3 to the power of y minus 1 is equal to 3 to the power of 2y. All right. This is leading us somewhere. It's leading us somewhere. All right. So now, you know what we're going to do? This is already leading us to a quadratic equation gently. So now we're going to take this to this side. Let us take all this to this side. So taking all this to this side here, it becomes 3 to the power of 2y is already here. Take this to this side, it becomes minus 2 into 3 to the power of y. Now take minus 1 to this side, it becomes plus 1. They will be equal, it will be equal to 0 because you are taking all this away from here. So nothing will be left here, so it will be equal to 0. Alright. So this is beautiful. This is beautiful. This is beautiful. We are going somewhere. Now let's find a way to express this 3 to the power of 2y in form of 3 to the power of y. Now how do we do that? If we write this as 3 to the power of y all into 2, this is still the same thing as this. Don't forget the law of indices that says if you have x to the power of a all into b, you can multiply the power inside and power outside, it becomes x to the power of ab. You see the same thing here. If you multiply 2 times y, you get 2y. So this is the same thing as this. Minus 2 into 3 to the power of y plus 1 is equal to 0. This is what we have now. From this, we got that x is equal to this equation 1, and we had this equation 2. Now, but we've simplified all this to get this. All right, using this and this to get this. Now, this is going to lead us to a quadratic equation, but we can't solve this direct. We are going to represent 3 to the power of y with something. So we can say let p represent 3 to the power of y. All right, you see, like p is equivalent to 3 to the power of y. You can also say let p be equal to 3 to the power of y. Any of them you want to say. All right, so doing this, anywhere we see 3 to the power of y, we're going to replace it with p. So it becomes what? P to the power of 2 minus 2 into p plus 1 is equal to 0. So this is going to be p to the power of 2. That gives us p squared minus 2p plus 1 is equal to 0. Now this has led us to a normal quadratic equation. So we're going to solve this quadratic equation. Now, how do we solve this? Now we're going to solve it using factorization method. We're going to solve this using factorization method. Now let's see how we can do that. Now we're going to use the equation of p squared to multiply the constant here. So there's an invisible 1 here. 1 times 1 gives us what? 1. So we're going to look for two numbers such that if we multiply both of them, they'll give us 1. And if we add them, they'll give us minus 2, which is here. All right. So what are those numbers? Now let's check. Minus 1 times minus 1, of course, gives us plus 1. Minus 1 plus minus 1, of course, is going to give us minus 2. All right. Because plus times minus, that gives us minus 1, which gives us minus 2. All right. So meaning that the factors are minus 1 and minus 1. Now having those factors, having realized those factors, what's going to happen is that we're going to replace those factors. So you have minus 1 and minus 1. So you're going to put p behind them, all right? Although the 1 will be invisible. So it becomes p squared minus p minus p. That's, you replace this middle, all right, which is minus 2p with the factors. But you still put plus 1 is equal to 0. So we are going to check what is common between p squared and minus p. P is common, all right? So it becomes p into p. You're going to be left with p minus 1, all right? Now, what's common between minus p and plus 1? What's common is minus 1, all right? So you're going to be left with p minus 1, all right, equals 0. Now, if you notice, the bracket and the bracket here is the same thing, all right? And so you just take this out. That will be p minus 1, all right? And you just take one of them because they are common. P minus 1, all right, is equal to 0. So it's going to be p is minus 1 is equal to 0, or p minus 1 is equal to 0. So it's simply going to mean that p is going to be equal to 1 twice. All right, p is going to be equal to 1 twice. All right, so now recall, go back, because you're not asked to find p, you're asked to solve the equation. That means you have to find x and y. Recall that that p is equal to 3 to the power of y, all right, which you said should here, all right, which you represented 3 to the power of y with p, all right. We represented 3 to the power of y with p. So now, meaning that you have gotten the value of p now, so replace it, so it becomes 1 is equal to 3 to the power of y, all right. Now if 1 is equal to 3 to the power of y, 3 to the power of y is also equal to 1. So we have to use this to find the value of y first. So how do we do that? Now I want you to know that 1 is 3 to the power of 0. You can still write this. You can still write 1 as 3 to the power of 0. Anything to the power of 0, don't forget, it's what? 1. So now it's like this takes this away, all right? So you are going to be left with y is equal to 0, all right? Y is equal to 0. Now you have to find the value of what? X too. You have to find the value of x. So recall from equation 1 that, recall from here, from your equation 1, all right? Recall from equation 1 that you have x is equal to 3 to the power of y. So substitute the power of y there, which is 0. Substitute y is equal to 0 into equation 1. So substitute it, you're going to have x is equal to 3 to the power of 0. And anything to the power of 0 is what? 1. So x is equal to 1. So the value of x is 1. And then the value of y is 0. Alright, so if you solve this equation, you're going to have x is equal to 1 and y is equal to 0. Alright, so this is the final solution to this question. That will be all for this Smash Jam series. Make sure you subscribe, like, and share this video. Do not forget to comment. Feel free to comment. Thank you.